Hi, I'm Ben Yonke with Golden Harvest Agronomy and Action Research. Today we'll be talking about soybean sulfur management. Recently, there's been a lot more concern with sulfur and sulfur applications. And some of the reasons why are our crops more recently are removing more sulfur. So higher yielding crops remove more sulfur compared to maybe 10, 15, 20 years ago. Um, there's also been a reduction in atmospheric deposition of sulfur. And so great visual of this is off to the right. You can see at the bottom there, in 2001, the areas darker in red were higher atmospheric deposition of sulfur. And due to the Clean Air Act and cleaning up some of the pollution in our environment, you can see the upper United States image there. A lot of those dark red areas with more atmospheric deposition of sulfur went away. And so good for our environment, but created a need for some of that sulfur in cropping systems. Also interesting to note, one of the soil labs we looked at, A&L Great Lakes Labs, for the state of Illinois, summarized their soil tests for each year. And so for 2005, their average sulfur parts per million for all of their soil samples was 14, and about 1% of samples that came in were either low or very low in sulfur. In 2020, average parts per million sulfur decreased to 9, and over half of their submitted samples were either low or very low in sulfur. Some of the basics concerning sulfur: 95% of sulfur is found in soil organic matter. That organic sulfur converts to sulfate and gets absorbed by the plant. It's limited in mobility in the plant, but highly mobile in the soil, similar to nitrogen in that respect. Some of the visual symptoms in soybeans include chlorosis in younger soybean plant leaves. Sulfur is important for storing and transporting energy. It plays a key role in protein synthesis and is a component of proteins and certain amino acids. For the 2020 soybean sulfur trial we conducted, we did 8 trials, and we had 2 sets of soybean varieties, 6 varieties each set. So an early set and a fuller season set in our southern geographies. And 4 treatments for each of those trials: an untreated check, granular AMS 210024, granular gypsum, 14% sulfur level, and a MES product from Mosaic, analysis of 1240-010 sulfur. Sulfur treatments were broadcasted pre-emerge, and we looked at a rate of 25 pounds of sulfur per acre. And you can see in the lower right there the pounds of acre per nutrient with each one of those 3 sulfur sources. If we look at our sites individually, we had some differences there. Sulfur availability is driven largely by pH. And so if an image in the upper right there, you can see when you fall below 6.0, we can start to see deficiency symptoms. Looking at the table there at the bottom right corner, you can see we had some variabilities in sulfur level. So off to the far right there, low or very low for most of our sites. Also important to note was pH. For a couple of those sites, they did fall below that 6 level. And organic matter was highly variable across all of our sites too, so ranging from a 1.9 to over 4%. So that likely led to an increase, or that likely led to variable sulfur mineralization. When we look at yield response by each of those three sulfur sources, soybeans were least responsive to the gypsum treatment. 6 of our 8 locations showed a smaller response to AMS and MES. MES was the only product with a significant yield response at Seward there. So in the far right, you can see that dark blue bar. If you look at this graph, the dark red lines there indicate break-even yield based on sulfur form price alone. And across each one of these 3 sulfur sources, varieties responded similarly to what you see here. If you're concerned about the economic analysis we performed on this, you can see there in the bottom there the different prices we used for fertilizer sources and soybean price. Remember that sulfur is a large component of protein synthesis, and so we were curious as to the effects sulfur applications had on protein. What we did find out is that varieties vary in overall protein content, and our growing conditions seemed to have a larger effect on protein content for each one of these trials. Increases in protein from sulfur was only observed at Cedar Rapids, Iowa. So you can see here in the bottom left, the protein level ranges by location, the variance there. And on the right-hand side graph, the protein level by variety. And so our takeaway from this, incremental sulfur isn't always needed. Probably more of a concern where you have lower organic soils. Highly organic matter soils mineralize more sulfur than low organic matter soils. And in our trials, supplemental sulfur improved yields where soil pH was low. Nitrogen and sulfur are key components for protein synthesis in soybeans, and we found the growing environment and variety selection affected protein content more than sulfur did. Other studies have observed an increase in protein content from adding sulfur. Our locations only observed one location where it increased protein content.